We're surrounded by all this tech that just works. It feels like magic, right? That is, until it suddenly doesn't. But what if I told you there's this invisible force, a secret ingredient that engineers use to fix, improve, and honestly invent everything from your phone to the entire internet? Well, that ingredient is data. And if you understand how it's analyzed, you're going to understand our whole digital world a lot better. Oh, you know the feeling. One day, your phone is a total champion. Lasts you all day, no problem. The next day, it's screaming for a charger by lunchtime. You haven't changed a thing, so what gives? What is going on under the hood? It just feels completely random, doesn't it? And it's not just your battery, right? Think about your Wi-Fi. It's been flying for weeks, and then boom, right in the middle of a super important video call, everything just grinds to a halt. These aren't just random acts of tech betrayal, I promise. They're problems, yeah, but they're problems with clues hidden right inside them. So the answer to fixing all these frustrations, it's not magic, it's not some wild guess. The real answer, the one that drives all of modern engineering, is data. See, engineers don't just cross their fingers and hope for the best. They measure, they analyze, and they let the numbers tell them exactly what's wrong and, more importantly, how to fix it. So what are we really talking about here? What is data analysis in computer engineering? Well, think of it as the science of following these digital breadcrumbs that all our devices leave behind. Every single error log, every sensor reading, every little blip of network traffic, it all tells a story. The whole goal is to take that raw, messy information and turn it into clear, actionable insights that lead to real, tangible improvements. And this is a huge shift in how engineering gets done. I mean, in the past, a lot of decisions were based on theory, or, let's be honest, educated guesses. An engineer might assume what the problem was, but today, it is all about hard evidence. So instead of just guessing, they can actually prove what's wrong with data. And that leads to improvements you can actually verify, not just wishful thinking. Okay, so this all sounds great in theory, but where does this actually happen? Where is it applied? The short answer is everywhere. I mean it. From the tiniest microchip in your watch to these massive global networks, data analysis is the engine of progress. Let's look at a few key areas to really see how it works. Let's just trace the path from the data straight to the result. In your phone, you've got embedded systems. Engineers are analyzing sensor data to optimize how energy is used, which, for you and me, means longer battery life. Simple as that. Or for the internet itself, they study network traffic logs to figure out better ways to route data. That reduces latency, which is that annoying lag you get on video calls. And for the apps we use every day, analyzing system logs helps them hunt down and fix bugs, which just leads to software that's way more reliable. It's a really clear, powerful line from data to outcome. So how do engineers actually measure success? How do they know if they're winning? Well, they focus on what we call key performance metrics. Think of these as the vital signs of any system. You've got latency, which is all about speed. How long is that delay? Then there's throughput, which is about capacity. How much can it handle? And finally, power consumption, which is all about efficiency. Is it wasting energy? Improving these three is almost always the name of the game. But here is the absolutely crucial point. This is not a one-and-done kind of deal. You don't just analyze the data once and call it a day. Nope. The best engineering happens in a continuous cycle of improvement, where every solution you implement generates new data, which then leads to the next round of optimizations. It never stops. And this is the engineer's blueprint. This is the process. It starts with step 1, identifying a very specific problem and setting a goal you can actually measure. Then, step 2, they collect all the relevant data, from logs, sensors, you name it. Step 3 is the analysis, where they use these incredibly powerful tools to find patterns and trends. And finally, step 4, they make a decision, implement a change, and this is key, they evaluate the outcome, which, you guessed it, starts the whole cycle right over again. And that first step is just so incredibly important. A goal can't be some vague thing like, let's make the network faster. It has to be specific. It has to be measurable. Something like, we are going to reduce latency by 20%. This creates a clear target, because without a number to aim for, how do you ever really know if you've succeeded? Wielding all this data gives engineers incredible power to build and improve our world. But it also comes with a pretty serious responsibility. It kind of brings to mind a famous saying, right? With great analytical power comes great responsibility. This isn't just about getting the right answer. It's about building things the right way. That means ensuring accuracy, so your results are precise and so other people can test them. It means being transparent, documenting your methods so the whole team can understand and contribute. It means pursuing fairness, making sure your systems don't have hidden biases that could affect people unfairly. And finally, it's about accountability, taking professional ownership of your work and encouraging others to review it to make the final product even better. So let's end with a question. The next time you see that app update that says, bug fixes and performance improvements, just pause for a second. Think about the hidden data story that's happening behind the scenes. What problem did an engineer somewhere identify? What numbers were they tracking? And what little insight did they pull from all that data just to make your digital life a tiny bit smoother? The answer's right there, running silently in the background.